is Bulega Faizo. Yeah, I want to explain about the computer generations. The definition of computer generation is this refers to the change in the computer technologies. It's like the technology the computer uses over years. Uh, First of all, I'm starting with the first generation, and the first generation technology of computer worked from 1946 up to 1959. The computers of the first generation used vacuum tubes as the basic component for memory and circuitry for central processing unit. These tubes, like electric bulbs, produced a lot of heat, and the installations used to fuse frequently. Therefore, they were very expensive and only large organizations were able to afford them. For example, like the government organizations. In this generation, mainly batch processing operating system was used. Punch cards, paper tape, and magnetic tape was used as an input and output devices. The computers used machine code as the programming language. They also had a typical speed which was not too much, and we have got the features of this generation where vacuum tubes technology was used, they were unreliable, supported machine language only, which is the low level language, very costly, generates a lot of heat, slow input and output devices, huge size. For example, like the computers were very big, they even consumed a lot of space, for example. And the next, need of SC, non-portable, they were non-portable, like they were too big, consumes a lot of electricity, like they used to take too much of electricity. Some of computers in this generation were ENIAC, ENIAC, EDIVAC, UNIVAC, IBM 701, IBM 750. We are on the second generation, computer generation. The period of second generation was from 1959 up to 1965. In this generation, transistors were used that were cheaper, consume less power, more compact in size, more reliable and faster than the first generation machines, and made of vacuum tubes. In this generation, magnetic cores were used as the primary memory, and magnetic tape and magnetic disks as secondary storage devices. In this generation, assembly language and high-level programming language like Fortran, COBOL were used. Therefore, we got some of the high-level language, for example, like Fortran, like which is more understandable to people, in that the low language is too difficult, like it's in symbols, more of symbols. The computers used batch processing and multi-programming operating system. Features of second generation: used transistors, reliable in comparison to the first generation, smaller in size as compared to first generation, generates less heat as compared to first, consumed less electricity as compared to the first, faster than the first generation computers, still very costly. SC required, supported machine and assembly languages. Some of computers of this generation was IBM 1620, IBM 7094, CDC 1604, CDC 3600, UNIVAC 1108. We are on the third generation. The period of the third generation was from 1965 up to 1971. The computers of third generation used integrated circuits (ICs) in place of transistors. A single IC has many transistors, resistors, and capacitors along with the associated circuitry. The IC was invented by Jack Kilby. This development made computers smaller in size, reliable, and efficient. In this generation, remote processing, time sharing, multi-programming operating system were used. High-level languages like COBOL, BASIC were used during this generation. Features of this generation, the third generation: IC used the integrated circuits, more reliable in comparison to the previous two generations, smaller in size compared to the previous generation, generated less heat, faster, they were faster compared to the previous generation, lesser maintenance, costly, AC also required in this generation, consumed lesser electricity, supported high-level language. Some computers of this generation were IBM 360 series, Honeywell 6000 series, PDP personal data processor, IBM 370 or 168, TDC 316. The fourth generation, the fourth generation was from 1971 up to 1980. Computers of fourth generation used very large scale integrated circuits, in brackets VLSI. The VLSI circuits having about 5,000 transistors and the other circuits elements with their associated circuits on a single chip, and it made it possible to have microcomputers of fourth generation. Fourth generation computers became more powerful, compact, reliable, and affordable. As a result, gave rise to personal computers, the PCs in short form. Revolution. This generation, time sharing, real-time networking, distributed operating system were used. All the high-level languages like C, C++, DBase, etc. were used in this generation. Features of this generation: VLSI technology was introduced, very cheap, portable and reliable, use of PCs, the personal computers, very small in size, pipeline processing, no SC required. On this generation, the fourth one, the SC wasn't required. Concept of internet was introduced, great developments in the field of networks, computers became easily available. Some computers of this generation, DEC 10, star 1000, PDP 11, Cray up to 1, super into bracket supercomputer, Cray XMP into bracket supercomputer. We are on the fifth generation, the last generation, the current one. The period of fifth generation is 1980 till date. In the fifth generation, VLSI technology became ULSI into brackets ultra large scale integration technology, resulting in the production of microprocessor components. This generation is based on parallel processing hardware and AI, the artificial intelligence into brackets software. The artificial intelligence is an emerging branch in computer science which interprets the means and methods of making computer thinking like human beings. All the high-level languages like C and C++, Java, Net, etc. are used in these generations. Therefore, these high-level languages in these generations are like near to the natural language which human beings understand. Like the features of the fifth generation computers, ULSI technology was used, the ultra large scale integration technology was introduced, development of true artificial intelligence, the development of computers which do think like human beings were introduced. That's the explanation of that. Development of natural language processing, like the development of the Python, the JavaScript, all the languages were introduced which are too near to the human language, like English. Advancement in parallel processing, advancement in superconductor technology, more user-friendly interfaces with multimedia features, availability of very powerful and compact computers at cheaper rates. Some of computer types of this generation, we had the desktop, laptop, notebook, ultrabook, Chromebook. that's the end of the computer generations. Now we are going to have a brief explanation about the evolution of the Intel x86 and ARM architecture. Here is just a simple brief about Intel x86 architecture. The Intel x86 architecture has evolved over the years from a 29,000 transistors microprocessors 8086 that was the first introduced to a quad-core Intel Core 2, which contains 820 million transistors. The organization and technology have changed dramatically, as we are going to see now. Starting with the 8080. It was the world's first generation purpose microprocessor. It was an 8-bit machine with 8-bit data path to memory. It was used in the first personal computers. Secondly, 8086. It was a 16-bit machine and was far more powerful than the previous one. It had a wider data path of 16 bits and large registers, along with an instruction cache or quirk that prefetches a few instructions before they are executed. It is the first appearance of 8086 architecture. It has a real mode and addressable memory of 1 megabyte. Now we are on 80286. It has an addressable memory of 16 megabytes instead of just 1 megabyte, which differentiates it from the 8086, and contains two modes: real mode and first generation 16-bit protected mode. It has a data transfer width of 16 bits and a programming model of 16 bits. We are on the fourth one, which is 80386. It was Intel's first 32-bit machine. Due to its 32-bit architecture, it was able to compete against the complexity and power of microcomputers and mainframes introduced just a few years earlier. It was the first processor to support multitasking and containing the 32-bit protected mode. It also implemented the concept of paging. It has an addressable physical memory of 4 GB and data transfer width of 32 bits. Now that's all about the Intel x86 evolution architecture. No, it hasn't been done. Okay, we are going still on the Intel 80486. It introduced the concept of cache technology and instruction pipelining. It contained a write protect feature and offered a built-in math core processor that offloaded complex math operations from the main CPU, the central processing unit. We are done with the Intel. Now we are on the evolutions of ARM. The ARM in full, it's advanced RISC machine, and RISC is also reduced instruction set computer. The ARM architecture has evolved steadily to respond to the changing needs of ARM's partners and of the design community in general. At each major version of the ARM architecture, significant features have been added. Between major architecture versions, new features have been included as variants on the architectures. The key letters appended to the core names indicated specific architectures enhancements within each implementations. Starting with the version 3, introduced 32-bit addressing, and architecture variant, the thumb state, 16-bit instruction execution, long multiply support. These features became standard in architecture version 4 onwards. Secondly, the version 4 added half-word load and store. The version 5 improved ARM and thumb network interworking, count leading zeros, or into bracket CLZ, instruction and architecture variants. Variants such as E standing for enhanced DSP instructions, including saturated arithmetic operations and 16-bit multiply operations. The J standing for support for new Java state, offering hardware and optimized software, acceleration of bytecode execution. All of them, they are TEJ. Enhancements above became part of the new ARM version 6 architecture specifications. Therefore, the ARM architecture will of course continue to evolve with appropriate enhancements in the future. That's my explanation about the Intels and the evolution of ARM architecture.